Alright guys, this is unit number 8, lesson 6. Today we're going to talk about the zeros of quadratic, which is good stuff. We're actually going to be solving quadratic equations, and the solutions are called the zeros. So, getting into some fun stuff here. So the x location on any function is where the output, or the y, is equal to 0, are known surprisingly as the zeros of a function. I'll explain that in a minute if you didn't quite understand that. These are amazingly important when we get to applied quadratics. You'll see that. That means word problems. When they are rational numbers, they can be found by using factoring techniques. So it's a good thing we know how to factor. Alright, so here's a quadratic. And what we're going to do is, what are the zeros of the function? Write their values and circle them on the graph. So remember, the zeros are basically where the y value is 0. So right there are what we call the zeros of the quadratic, because the coordinates of this would be -1, 0. The coordinates of this would be 3, 0. Oops, it's supposed to be a dot. So that is what are the zeros of the quadratic, basically where the quadratic intersects the x-axis. That's it. The quadratic is this guy here. So we would write them simply like that. So there's one answer, and here's a second answer. And you'll see that we could have 2, 1, or sometimes no answers. We'll get there. Alright, now verify that the positive 0 is the correct by showing that y equals 0. So the positive 0 is this one. And what they want you to do is basically plug it into that and prove that when you put in the input of 3, you get out a 0. So do that now, please. Hit pause and give that a try. Alright, did it work out for you? Let's see the work you should have done. So you can see here's our quadratic. We're going to input the 3 for the x, and when you do the math, it comes out to be 0. So this is showing that the input value of 3 gets out of 0, and that's why we call it the zeros. Now, I want you to factor this, and then look at the factors and compare them to the zeros. So you should all be able to factor this. And then notice there's a relationship between the factors and the zeros. So do that now, please. Okay, so when you factored it, it'll come out looking something like that. So here are the factors. And you can see that our zeros were -1 and +3, which you can see are pretty much the exact opposite of these numbers here. And I'll show you it's going to make a lot of sense why that will always happen. It will make a lot of sense. And you know what? I'm just going to show you in this problem. Think about the zeros means that this thing equals 0. So if I made this parentheses 0, so if I put in -1 in for x, -1 plus 1 would be 0, and that parentheses would become 0, and then it really doesn't matter what this other one is, because 0 times anything will be 0. So putting in a -1 for x will create a 0. Same thing here. If I put in +3 there, +3 and -3 make 0. Now I'm doing 0 times something, and it will always equal 0. That's the concept behind it, and I'll explain it one more time, and hopefully it will make sense. So down here, based on C, determine the zeros algebraically of this one right here. So look what we did. Remember, we factored it, and then could we come up with the zeros? So do that for this one. Then you could verify using your table. So see if your answers are correct, because see if the x inputs you identified get you a y of 0. So you could put it in this in your calculator and bring up the table to verify. So do that now, guys. Alright, how did you do? Let's see how you factored it. It should factor out like that. We know that +5 times -2, that would get the -10, and +5 minus 2. Now looking at just this factor, and what we talked about, these factors and the zeros, were you able to come up with the correct zeros? And hopefully you got one of them is -5. And again, the reason is that is we are trying to, remember our goal is we want this to equal 0. So if I made this part alone 0, well, that would be 0 times some number, and it would equal 0. So that's perfect. So putting in a -5 in there makes a 0. Same thing happens with the other set of parentheses. if I make this one over here 0, if this thing becomes 0 by putting a 2 in there, 2 minus 2 is 0, then it doesn't matter what goes in here because I will always get 0 when I multiply by 0. So these are the zeros, meaning if we put these x's in this equation, we'll get out zeros. All right, we'll keep working with this and you'll get it. It's not so bad. All right, and what I was talking about, the really reason this works is because we have a zero product law, and this will help us out. The zero product law basically says that if A times B, so just any two numbers, we got one A, one B, and when you multiply those, if it gets 0, then either A has to be 0 or B has to be 0, or both can. Because remember, it's something like this. 3 times 0 is 0. 0 times 6 is 0. So as long as one of your factors is 0, your product will be 0. And obviously they both can because 0 times 0 equals 0. So that's what the zero product law is talking about. And basically we want to make this 0, we just have to make this piece or this piece equal 0. That's it. So I could show you one of these and you should be able to do the rest. So to make this one 0, you still have to show work. I think most people understand that if I just put a -7 in there, that would make this 0. But with algebra, we've told you a million times, you have to have work to support your answer. So you just take this factor, set it equal to 0, and this is a really simple equation to solve. You can see I could just subtract 7 from both sides, and now I know x equals -7. So why don't you do the same thing for this one and show me what would be the 0 for this factor. Okay, did you get something like this? So again, you set that factor equal to 0, solve the really and the way you want to write your answers looks like this. Notice that it's not a parentheses around here, those are brackets. If you put parentheses around it, it would look like a point. That's not what we're saying. Brackets is for a list of things. So there's two actual solutions to this equation. So these are the two solutions. All right, could you do B alone? This one's a little harder. So could you come up with what x equals? Whoa, let's not do that. So what would x equal like we have over here? And could you find the final solution? If not, I'll show you, but see if you could try it. So hit pause and give it a try. All right, for our first factor, remember what you want to do is set it equal to 0. So 2x minus 1 equals 0. Let's get rid of that. Okay. Then just solve that super easy equation. Add 1 to both sides, divide by 2, x equals a half. Because if you put a half in there, half of 2 is 1. 1 minus 1 would make that 0. Second factor, again, just set it equal to 0. Subtract 4, divide by 3, and you're going to get -4/3. So that one's a little more difficult. And your solutions, we want to write them out somewhere. I have them somewhere. I think I do. There we go. So there's the different solutions for this one. Typically, when you write them out, you do smallest to largest. So you can see this is a -4/3. That's what it was supposed to say here. And this is 1/2. All right, so with that idea, now we're going to put everything together and see if we can come up with these when they give us as a trinomial. So the zero product law is remarkable because it allows us to solve equations in the x squared or higher levels. As long as the expression is set equal to 0, it can be factored. So find the roots of the solution. The roots is another word for finding the zeros. This is important, so you might want to write that down. On your regions, it might say find the roots, find the solution, find the zeros. It's all referring to the same thing. Okay, you could write better than me. So all three of these, roots, solutions, zeros, referring to the same thing. All right, so I will help you with the first one, and then you could do the rest on your own. So the first thing you're going to do is factor this. So when you factor it, you should get something. Oops, I messed up, but there we go. We should be able to factor that trinomial fairly easy because 6 times 2 is 12, and 6 minus 2 is the 4. So you should be good at this factoring now. Then you take each of your factors, set it equal to 0, and just solve. So there is your first root, we would call this, or your first 0. And then just take your other factors, set that equal to 0, and there we go. So these would be the roots, or the zeros, or the solutions, and you want to write it in these brackets. You don't have to write out the words final solution set, but it's called a solution set because there's more than one thing. So see if you can do the rest of these on your own. So hit pause And remember, you solve by factoring. So I'll give you hints. Remember, we had GCF factoring, we had dots factoring, and also factoring when the leading coefficient was greater than 1. So it's not always the exact same factoring. So give that a try, see how you do. Alright, let's take a look at these. So how did you factor this one? Hopefully you recognize there's a GCF on this one, and it would just look like that. Now, what you have to recognize is that 2x is one factor, and the x minus 7 is another factor. You do not need to break it down to 2 times x. Oh, this new laptop is not as good. And then times, so don't split the 2 times x into 2 separate factors and say there's 3. This is a monomial, this is a binomial, so those are your different factors. So now, just like before, take your 2x and just set it equal to 0. Now that's obvious. 2 times what is 0? You could still solve the equation, and now therefore that's one of your zeros. If I put, and think about that, if you put 0 into this equation, you could see that this would be 0 squared times 2, which would be 0. 14 times 0 is 0, and 0 minus 0 is 0. So that is a viable answer. Then you're just going to take this other factor, set it equal to 0, there you go, and write your final solution somewhere. Perfect. Alright, for question C, hopefully you recognize that was a dot's a difference of 2 squares. So it should factor out like that. And then we're going to take the left factor, set it equal to 0. The right factor, set it equal to 0. And yes, some of you guys are going to hate us, but you have to show this work. You can't just say, hey, guess what? This is x equals 5, because I'm a really smart person and realize that if I put 5 in there, that makes it 0. You still have to show the work on how to get answers. And then write your solution somewhere. Where's it? It's like finding the Easter. Oh, it's down there, close to Easter. So I'm like hunting for it. And notice that some of you guys have seen this come up before. This is a symbol you should get to know. When you see a number that says this means plus and minus 3. Mathematicians were lazy, so anytime we can make shortcuts so we don't have to write extra stuff, we can. So this is an actual math symbol. It means plus and minus at the same time. So this is positive 5 and negative 5. So you could write it like that or like that. Alright, last one. Now this was the harder type of factoring, so let's see if you remember how to do it. Hopefully you factored it into those two right there. And we take our left factor, set it equal to 0. You know it's going to have fractions when you have something in front of the x. So add 3 divided by 2, there we go. And here's your other one. Now you could check these anytime by simply taking the number, plugging it into the equation, and seeing if you get 0. So anytime you want, you can check your answers. And there's your solution. There it is. Alright, and I believe that is it. Let's just make sure. Oh, no, good thing I checked. Alright, so last time. So we have this quadratic here. They want you to find the zeros algebraically. Let's switch there. And then we're going to verify with our calculator. So you guys at this point should be able to find the complete zeros of this quadratic. So give that a try now. And just don't do it on the graph, just do the algebra part. So hit pause and try that, please. Okay, now on this one, did you recognize that the first thing you should do when you factor is always look for GCF, and 3 goes into everything, so you should have factored out the GCF first. It would have made things a lot easier for you. Once you did that, then this was pretty easy to factor, and here are the factors of the quadratic. Now, when we tell you to make each factor equal to 0, does it even make sense to try to take this 3 and make it equal 0? I can't say like 3 equals 0. I can never turn this 3 into 0. So this one you don't have to worry about. And the reason is, obviously, if you can make this part 0, then 3 times 0 is still going to be 0. So when you have a single number, just ignore that. We're really looking for the variables. So now, let's take this factor and set it equal to 0. Let's take this factor, set it equal to 0. And there's our solutions. And that's just kind of what I talked about right there. Solutions are somewhere. There they are. Okay, so quickly, what you're going to do is put the quadratic in your calculator. Use these tables, or these windows, and graph it and see what happens and see if it verifies these. So do that now. So hit pause and I'll show you what your graph should look like. Alright, did your graph come out looking something like this? Hopefully it did. You're just sketching it, but notice that it did hit the x-axis at -2 and 4. You could verify using your table. And you guys just learned how to solve quadratic